Introduction. Newton's laws of motion are foundational principles in physics that describe the relationship between motion and forces. In this comprehensive exploration, we delve into the significance of Newton's three laws, their practical applications, and how they shape our understanding of the physical world. Newton's first law of motion, inertia. According to Newton's first law of motion, an object at rest will remain at rest, and an object in motion will continue moving at a constant velocity in a straight line unless acted upon by an external force. This principle is often referred to as the law of inertia. In other words, objects resist changes in their motion, whether it's starting, stopping, or changing direction. This law helps explain why we feel a force pushing us forward when a vehicle suddenly stops. Newton's second law of motion, F equals ma. The second law of motion states that the force acting on an object is directly proportional to its mass and acceleration. Mathematically, this law is expressed as F equals ma, where F represents the force, m represents the mass, and a represents the acceleration of the object. This law helps determine the relationship between force, mass, and acceleration. For example, to accelerate a heavy object, such as a car, a greater force is required compared to a lighter object. Understanding this law is crucial in engineering, sports, and countless other fields. Newton's third law of motion, action and reaction. The third law of motion states that for every action, there is an equal and opposite reaction. This means that whenever an object exerts a force on another object, the second object exerts an equal and opposite force on the first object. This law emphasizes the symmetry of forces and how they always occur in pairs. For example, when you push a wall, you exert a force on it, but the wall also exerts an equal and opposite force on you. This law is fundamental to understanding motion and force interactions in various situations. Practical applications of Newton's laws. Newton's laws of motion have numerous practical applications in everyday life and various fields of science and engineering. These principles are used in designing vehicles, calculating the trajectory of projectiles, understanding the mechanics of sports, and predicting the behavior of celestial bodies. They provide the foundation for concepts such as gravity, friction, and energy conservation. Impact on our understanding of the physical world. Newton's laws revolutionized our understanding of motion, force, and the physical world. They laid the groundwork for modern physics and enabled advancements in areas such as technology, engineering, and space exploration. Newton's laws continue to serve as the basis for further scientific discoveries and the development of new theories. Conclusion. Newton's laws of motion, comprising the laws of inertia, force, and action and reaction, fundamentally shape our understanding of motion and force in the physical world. These laws provide a framework for predicting and explaining the behavior of objects and systems around us. From the mechanics of everyday objects to the movements of planets, Newton's laws have a profound impact on various scientific and practical applications. By unraveling the principles behind these laws, we can delve deeper into the intricate fabric of the universe and unlock a more profound understanding of our dynamic world.